and welcome to the first ever episode of Mind Over Misinformation. I'm your host, Ananda, and I'm so excited to bring this project to life. This show is all about the place where science, culture, and nutrition collide. Each episode will take a closer look at the health messages we grow up with, the ones we see in the media, on our feeds, or even in everyday conversations. Together, we'll unpack the cultural forces that shape our beliefs about food and the body while grounding everything in real biochemistry and public health research. From protein obsession and carb fear to caffeine culture, fasting trends, dairy myths, stress eating, sugar highs, and everything in between, you're going to hear the stories behind these ideas, where they came from, and what the science actually says. While this started as an academic project, this has turned into a space I hope to continue long after the assignment ends. This podcast will be a place to explore nutritional anthropology, debunk misinformation, and talk honestly about how culture shapes our understanding of health. So thank you for being here for episode 1. Let's get into it. I'm joined by Zoe Littlefield, who will be stepping in as the voice of our listeners. Zoe will be the person to ask some of the questions we all want to explore and will help keep our conversations grounded and accessible. Zoe?
Hello, I am Zoe. I am a Hampshire College student. I study neuroscience and microbiology, which is why I'm here at all, I guess. And I've known Ananda since day one in our freshman seminar. Orientation. Been lab partners ever since.
Oh, yeah.
And I also drink coffee every day.
That's awesome. I don't drink coffee. I drink tea. I drink tea every day.
Which also has caffeine.
It does.
Which is the topic of today.
Exactly. So when you think of caffeine, what comes to mind?
The first thing I think of, I think of coffee immediately. I think of the coffee I drink every morning.
What's your coffee order?
Oh gosh, well it changes, but it has to be something sweet. So I usually do a dirty chai with oat milk at the Kern Cafe.
It's a good option.
I also go with, sometimes I'll do a mocha, which is even more caffeine.
Yeah.
Because of the chocolate.
Yeah, exactly.
In the cocoa beans. Actually, I had done some research prior to this.
You're so on top of it.
Exactly. And it says that the FDA reported safe, moderate coffee drinker is dosed at 300 milligrams a day.
That's what I saw. Like, you cap it at, 200 to 300. Or at least you should. Isn't it that you shouldn't really reach it, but that's just, the safe amount?
That's, I think that amount you'll be fine.
Yeah.
And then...
Well, for certain people. Because if you do, that one girl, if you have a heart condition...
I guess that's true.
Then it really depends. Doctor. Yeah, and listen to your body,
it says high doses... Oh, my gosh. It says high doses between 500 to 2,000 milligrams.
That's a lot of caffeine.
That's a lot. Yeah.
It's multiple energy drinks.
Yes, which we'll get into
later.
Will. But also I found that this one 2009 study found that 90% of Americans and European adults consume caffeine on a daily basis with an average dose of 227 milligrams.
A lot of caffeine. So, well, I have a stat later on as well.
Oh, interesting. So we have a lot of caffeine usage. It's very normalized.
It's very, exactly, especially in Western culture. But specifically coffee.
Yeah. And our caffeinated sodas.
Yeah, and energy drinks. Well, energy drinks more so along, for a younger population, especially college students, I would imagine, high school, college students.
And even younger, younger kids will be having energy drinks, and that's probably a lot of caffeine for a little body.
Yeah, well, it's also, when you think of the marketing around caffeine, it's a fun little thing. Everyone's doing it.
It's yummy flavors.
Exactly.
My other stat that I had found was that 54% of American adults consume an average of 3 or more cups of coffee a day. Study done in 2008. So...
Each day they consume more than 3 cups of coffee.
3 or more.
3 or more.
That's the category they fell in, yeah.
I mean, I believe it.
Yeah. I mean, America runs on Dunkin'. I mean... I think part of that is our society being so capitalist, like American work culture. And because caffeine is a stimulant, it lets you do more work.
So, like, back when you would get the, like, lower class to work in the factories and everything, I'm assuming you would give them coffee so they could do more work and get more stuff done and stay alert for longer when they were working longer
It's how
hours.
you're able to push yourself beyond your natural limit.
Exactly.
Yeah.
And if you're working really long hours before, like, the work safety was implemented as well, then you'd be going to bed late, waking up early. You need to keep going somehow.
Right. I mean, people used to do, like, 16-hour work days.
Yeah.
Little thought of caffeine sources, like tea, like sodas, well, obviously the energy drinks. With coffee, I think of also the way coffee has become like a whole business, like shops, coffee shop. I mean, there's multiple different chains.
Yeah, exactly.
It's part of our culture. It's ingrained.
Well, you see even like coffee shop brands in supermarkets as well.
Right.
Especially the more popular ones within your like point of view when you're walking around. Yeah.
And I mean, I think caffeine as a whole is a hugely popular substance. Objectively mind-altering substance, psychoactive. And I would guess that it's probably one of the most used substances out there.
Yeah. I mean, it probably is. That's what I would assume as well, just because it's in so many things. And this is actually a great segue into where caffeine is found. It's found, like you said, in coffee beans, cacao beans, and tea leaves, as well as cola nuts, yerba mate, and guarana berries. And then you also mentioned that it's added to various products, like soda energy drinks, but it's also in some pre-workout powders.
That'll get you going.
Exactly. It will. I mean, you'll be able to just stay at the gym longer. You'll have more energy if you are given a stimulant. So for the listeners who don't know, that means that it increases chemicals called neurotransmitters in your brain, which excite your central nervous system, or CNS. And the CNS is the processing center that regulates everything your body does. And so just a little bit of caffeine can help you feel more awake, alert, and focused, but too much can cause side effects like jitteriness, stomach issues, heart palpitations, and more. And so moving on to misconceptions, because I feel like we've given a good, like, beginning, right? What are potentially some negative things you've heard about caffeine consumption?
Well, I've heard, I mean, everyone says that X, Y, or Z substance causes cancer, that caffeine, they say, is a diuretic, so it can cause dehydration, that it can stunt your growth if you drink coffee as a child.
I also found that caffeine causes dehydration. I found that caffeine can cause breast cancer. Saw that caffeine can stunt growth in children and causes heart problems. I also saw that caffeine flushes calcium from the body, and it can cause ulcers. It can be super bad for pregnant women, or that it sobers you up when you're, like, under the influence.
I've also heard about coffee for hangovers, but I don't drink, so I don't.
Yeah. Well, I also saw, like, one of the things that's really common for more frats is to mix caffeine and alcohol.
Ew.
Because then you get the depressive effects from the alcohol, but you don't feel it as much because you have the caffeine.
I guess that's, like, what they...
And that, like, really messes up
I guess
head.
I've seen some people do, like, I'm thinking about, like, a vodka Red Bull. From what I've heard, it causes a worse hangover.
I can imagine, because your brain is being, like, thrown for a loop as far as,
I wonder
do you want
if
me
that
to...
would cause seizures. I wonder if there's any sort of, like...
I mean, I wouldn't be surprised if, at least in like, some people...
Yeah, don't do that if you have prone to seizures.
I would say just don't do that in general. And then another thing that I saw was that caffeine is as addictive as illegal drugs as well, which I thought was really interesting.
That's a bold claim.
Yeah.
I mean, it's probably just as used, if not more.
Right.
But
as addictive,
that depends on how we're defining that.
Exactly. And so I wanted to also put in a quick disclaimer that these myths refer to moderate caffeine consumption because many of them are exaggerations or misunderstandings of what the research actually shows. So like when I mentioned the myth that caffeine causes insomnia, I am in no way saying that caffeine does not disrupt sleep because it's a stimulant, so it will. It's just that the blanket statement is inaccurate.
Yeah, it's a generalization.
Exactly.
Right.
It could be taken out of context or misinterpreted incorrectly. So, yeah. And then, before we move on, which one do you want to talk about and dive into?
Well, so let's dive into the illegal drugs thing, because where is that coming from?
Right.
And how much of a concern should we really have about caffeine?
And, like, what's the comparisons between caffeine and illegal drugs, I think, is also very interesting.
I mean, is it the same?
We'll find out. So for some background, and to unpack this misconception, I think we should clarify some definitions. I think that's where we should start. And then we can also look at the biology of caffeine metabolism compared to the illicit substances and their neurological effects.
Awesome.
Yeah? Okay. So, starting with the definitions, according to the APA Dictionary of Psychology, addiction is a state of psychological and or physical dependence on the use of drugs or other substances or on activities or behaviors. The term is often used as an equivalent term for substance use disorder or substance dependence and can be applied to non-substance related behavioral addictions, and a chemical substance with significant potential for producing dependence is called an addictive drug. And similarly, I found that Merriam-Webster adds that addiction involves a compulsive, chronic, physiological or psychological need for a habit-forming substance or behavior and typically causes well-defined symptoms like anxiety, irritability, tremors, nausea upon withdrawal or abstinence. I want to dissect these definitions. Was there anything that stood out to you?
Well, I guess I would say then I guess I would define myself as addicted to caffeine. I mean, I do my coffee every morning, and if I don't, I have a headache. I might have a decreased mood. I'll probably be tired. So in those ways, I certainly have a habit, or like I guess a dependence. Yeah, I would say so. To keep me awake, to get me ready for my days. Especially if I'm about to go to work, I always get a coffee before. So in that way, I think the first one certainly would apply. So
yeah,
that one hits home.
Yeah.
Merriam-Webster. I mean, is it compulsive, chronic? Do I guess compulsive in the sense that it's routine?
I think compulsive in this context, at least how I took it, was like if you go one day without it and it's like usually around the time that you would get it, then you're like itching for it, like you need it. Like you will do anything to get it.
I guess it depends on to the degree. Like I can manage a day, but I will have symptoms. So let's see. So we're saying the withdrawal is anxiety.
Those are some of them, yeah.
Okay, anxiety, irritability, tremors, or nausea. So I wouldn't say it's that bad. Maybe irritability.
Yeah. Well, I mean, if you have a headache and you still have to go about your day, anybody would be irritable.
But I will also say, I certainly do get anxiety when I have too much coffee. I guess just because it gets your heart racing.
Exactly.
So I never do. I try to keep it to my contained 1 cup in the morning.
I think that's healthy. Yeah.
Thanks.
And healthy in the sense that it's not too much for you.
Yeah.
Yeah. So you mentioned dependence, how you might be also dependent on caffeine as well. So I wanted to unpack that definition.
Sure.
And so back to the APA Dictionary of Psychology, they define dependence as a persistent pattern of repeated substance use resulting in a strong internal drive to continue use, tolerance to the effects of the substance, and withdrawal symptoms if use is suspended. So what stood out to you from this definition?
Well, so I would say I can relate to withdrawal symptoms if use is suspended. Tolerance to the effects. I guess that's really over time. I've been pretty consistent long term, so I don't know that one super applies to me. Strong internal drive. I guess it gets me out of bed. I get ready to go to my current every morning.
Yeah.
And on the weekends, I still make myself coffee, but that's more to, oh my gosh, maybe it does sound bad. It's more to avoid the withdrawals.
Yeah. Well, like, do you enjoy the act of making coffee?
I do. I mean, I like the taste of coffee. I enjoy the ritual. I think it's nice to have just a little drink.
Yeah.
It feels good to have something warm. I think that's like a generally like human happy thing.
So there's a lot of positivity surrounding your experience with drinking a coffee.
Yeah.
Yeah.
I guess that might be a distinct difference. Is I don't know that coffee has ever caused severe issues in my life the way you would think about an addiction.
Right, exactly. And so looking at both of the definitions together, do you notice any like differences? To me, they're like pretty similar. And so I did go on to look up an easier way to find their differences, but I wanted to see if you thought of anything.
I think they all have similar points, but they use different wording, which is interesting. So, in the APA dictionary, we talk more about like the way that it can be defined as like something like more of like a dependence versus addiction versus just use, whereas in our other definitions they feel a little more medical, perhaps like withdrawal or abstinence,
like if you were to diagnose somebody,
right? Yeah, it feels more medical.
Exactly. And so when you're looking at both of the APA definitions, at least, it looks like dependence can be an addiction, but I'm not sure if they're reversible. Just because it's like dependence is mentioned in that definition, but addiction is nowhere near the dependence definition. And it also sounds like addiction is definitely stronger. There's a stronger drive to keep using the substances.
Really, because also the way I think about it, just when I think about it when it comes to mine, is like I kind of think of addiction more as like the psychological side, where I think of dependence as more of the biological side.
Like more physical?
Like, right,
Yeah.
like dependence in terms of like homeostasis versus in terms of behavior, which I think would be
Right.
the side. I think there are different levels of your functioning.
Yeah, and I get into that a little bit as well, as far as how dependence could be definitely more physical than it is the psychological of addiction. So I think that's a great connection. I looked at the Cleveland Clinic, and there was a really good article that I found. And they just, like, very simply just described that dependence means your body relies on the substance in order to function. So that would definitely be more of the biological.
Absolutely.
And addiction is when you continue to use a substance despite negative consequences. And they did explicitly note that not everyone with an addiction is chemically dependent, and vice versa. Not everyone who is chemically dependent has an addiction. And I thought that was also interesting.
Yeah.
And so, do you have any other thoughts?
Do you have an example of what
I do.
Oh, okay.
I know.
That would be helpful.
So, when, okay, so you can be dependent on a substance needed for your health, and it's not necessarily a bad thing. Like, people with diabetes need insulin.
Okay.
Right? So they're physically dependent on something, but I wouldn't say anybody who's diabetic is addicted to insulin.
No, I mean...
That would be a crazy claim.
Addicted to life.
They just want to keep living. And then also people with hypertension need blood pressure medications, right?
Okay.
Those are also not addictive. Addictive things can be put in them, sure, but like by themselves they are not addictive.
It's something to keep your body working the way it should.
Exactly. And so dependence can turn into addiction, and so using that same Cleveland Clinic article, they give a really good example where two people get in a car accident.
Okay.
Unfortunate situation. They're both badly injured, and they're both prescribed opioids to help manage their pain.
Okay.
As they heal, their bodies have become dependent on the medication because it's relieving their pain.
Mm-hmm.
One person follows the provider's guidance and safely stops the medication. They no longer need it and are not dependent on the substance anymore. They clearly don't have an addiction. On the other hand, the other person who also became dependent on the medication also became addicted to it.
Mm-hmm.
So they're unable to follow their provider's guidance for stopping the medication and now seek illegal ways to acquire the drug so they can keep taking it. For the second person, their dependence has become an opioid use disorder or opioid addiction. So, what are your thoughts on that?
I think it's, I would also like to point out that even though the first person may not be addicted after that first instance, that does not mean that the over-prescribing of opioids is not still going to affect them. They're not immune.
Right, exactly. Well, an opioid addiction is like the number 2 public health issue across America. It's it's huge.
I mean, we have so much more research to do for sure.
100%.
But we know how biological addiction is and how we really need to shift our perspectives away from this kind of like blaming
the person,
kind of like just like finger pointing to people who are really just existing in the way their brain was meant to exist to adapt to its environment. I mean, you might get lucky and not develop, the pathways that have you coming back to a certain drug. But yeah, so I guess my overall point is that nobody's immune. It's a physical thing in your brain.
Well, and also it can be like situational. If you're in like an overpopulated area with one hospital, right, then you might just get lost in the cracks. It could also be more normalized too, the use of opioids, depending on where you are.
Yeah, might not be given an alternative or a solution for when you don't have it anymore.
And so, after reading that, at least there were like 2 big questions that came to mind. I was really interested in how does addiction work, because if certain medications or certain substances can get people addicted, why can't others? And then the other one was, how is this related to caffeine? Right? Okay. I mean, it's related to our topic, but
we'll bring it back full circle.
Exactly. And so for these questions, I wanted to further explore the first question first with some neurobiology, which I thought you'd be interested in as a neuro major. To do this, I think we should start with addiction and what it looks like from a neuroscience perspective.
Nice.
What do you think about that?
Let's do it.
Yeah? Okay. So, our brain, we talked about this a little bit in our hormones, brain behavior class.
Yep. With
the reward system. So our brain has a reward system that reinforces behaviors necessary for survival, like eating and reproduction. And this system encourages us to seek positive stimuli, like food, and avoid negative ones, like pain. And so we as humans, we're creative, and we've found other methods of triggering this reward system through our ability to purify and deliver drugs, like cigarettes or syringes, putting in more alcohol in beverages, as well as advances in pharmacology, so creating the synthetic opioids and stimulants. And then when you combine these access to drugs and promotive environments, which could be chronic stress or peer pressure and individual vulnerabilities, like pre-existing mental illness or chronic pain, you have a great environment for addiction. And so as far as the neurobiology, I found a fantastic source that explained it very in depth, which is called The Neuroscience of Drug Reward and Addiction by Volkow et al. From the NIH and NIDA. And they went into it very in depth. I am not going into it that in depth. Like I don't know if I completely understood it. Even with my neurobiology course, there were still some things that were way beyond my scope.
Fair enough. But do they do a good job summing it up?
They do a fantastic job. They cover, I think they cover everything. They might not think they did, but I think at least they cover a lot.
Okay.
And so you might not be familiar with all of the terms. You probably are, but if you have questions, just jump in, or if you think we should explain something further.
Yeah, I'll see if there's anything I think we need to elaborate on.
Yeah. So here's the simplified explanation. It still is very science-y.
Okay.
So when we encounter a rewarding stimulus, the brain responds by increasing the release of the neurotransmitter dopamine. And dopamine lies at the center of drug reward, as all addictive drugs, regardless of which neurotransmitter they primarily act on, cause a dopamine increase. Caffeine is included in this. And this can occur with direct or indirect effects on dopaminergic neurons in the ventral tegmental area, or VTA, resulting in the release of dopamine in the nucleus accumbens, which is also the NAC, the central hub of addiction, via the mesolimbic dopamine pathway. And so what I think is the most important thing to remember is that dopamine lies at the center of the drug reward system. All addictive drugs cause some kind of dopamine increase, and the nucleus accumbens is the central hub of addiction.
Yeah, so we think about dopamine as like the reward or the pleasure hormone. So that makes sense. In addiction, it's the thing that tells us to keep doing what we're doing. So when that's being triggered, we have a drive to continue doing as we are. So I guess that's how it works here. I don't know that the brain areas are necessary for us to go over.
That's okay. Yeah, that's what I was thinking. Like, there's probably going to be people who know either a lot about this, or some people who are kind of interested or just want the key takeaways. So, I mean, the information is there. The source is fantastic for people who are really
go
want
check
to deep
out
dive.
the review. Go
check
check out the article.
I know that it's fantastic.
It's PubMed.
I also saw when I was doing my research that there was this one article. I can link it if I can re-find it. It was basically like, when you first start taking drugs, then they affect your dopamine levels, but after a while, you can start having the dopamine increase before you even take the drug or when you think about it, just because you've associated it so much that your brain is like excited just even thinking about it. It's, yeah, very interesting.
Yeah, I mean, from what I've learned in neurophysiology, I mean, when we have dopamine release and we're repeatedly sending our electric signal across the same string of neurons all in a loop together, all in the soup of your brain, they physically will grow closer together. They will, with their dendritic spines and their little arms reaching out to hold each other's hands,
they're so cute.
They will either grow their arms in certain directions and they'll make them shorter in others to be making the most efficient route to continue following this pathway. It's a neurotransmitter modulated response to continue to be as efficient as possible when we're encountering these kind of substances, especially when we're being rewarded for it.
Yeah. And so we've already explored this link in class, but I thought it would be interesting to just re-look and see the dopamine increases with the different kinds of drugs. And so what we're talking about is basically this simulation from the University of Utah called Mouse Party, which shows the specific direct effects of certain illicit substances.
Party. It's great.
Yes.
You should check it out. Okay.
So we have it open. So which ones do you want to look at?
If we do a playthrough here, let's start by looking at let's look at the cocaine mouse, because I guess we think of stimulants. I think coffee, cocaine. Are they the same?
Let's find out.
Okay, so if we get into this mouse's brain, and we give it a little bit of cocaine,
Well, that's dopamine right now.
Okay. So, okay, let's orient what's going on here. So dopamine transporters are responsible for removing dopamine molecules from the synaptic cleft after they've done their job.
So that's what we just saw.
Okay, so that's just standard. That's just regulation. So we don't have a bunch of extra chemicals and stuff in our synaptic cleft, which is the space between two neurons. Okay, so if we introduce cocaine, those reuptake receptors are, or transporters, I should say, are blocked. And so there's dopamine being left in the space between these two cells. So that means,
go in the others.
Right, so it can't be transported away to be degraded. So it has the opportunity to bind again with our postsynaptic cell here.
Well, not necessarily the opportunity. It's kind of forced. If it can't leave,
That's
where
true.
else is it going to go?
I mean,
it's
theoretically,
just bind
it can drift away, but
yeah.
Or maybe we have a glial cell coming to eat the
right.
the
but if there's
excess.
so much dopamine,
right? No, when you don't have our main transporters open anymore, it's stuck in the cleft. We're binding even more with our dopamine receptors. So we're in the reward pathway, but so Coke also affects our movement, our voluntary and involuntary movement. Okay.
So that was cocaine. Very simple, but and easy to understand as well.
So, I guess, and if we're thinking about the addictive aspect, dopamine is our feel-good, our pleasure hormone.
It's nice to have a dopamine rush.
It's nice to have a dopamine rush. Our reuptake is reduced, so we have a huge increase in our feeling of pleasure, of let me keep doing this.
Right. It's positive reinforcement, positive stimuli.
Exactly. Okay, so let's look at it. How are we looking at the methamphetamine?
Okay.
That's a different stimulant. Let's see how it's different or the same. Okay, so we have... Oh, I think it might work very similarly. Okay, so... in pretty much the same way, we have our dopamine in its typical form, I guess. We're having dopamine release between cells. That's just constantly happening, well, if we're, like, doing some task we enjoy. And so the excess will be transported into another cell to be broken back down or used again. So our synaptic cleft is going to be empty, free of excess neurotransmitters, which means once our dopamine binds, that's it. It's getting recycled and taken away. That's in a normal situation, in a non-drug situation. Okay, so if we introduce methamphetamine, or meth for short, so meth...
It doesn't block.
It doesn't block.
It is
it's
a little
different.
different.
It's different.
Not the same drug.
Methamphetamine is a similar enough shape to dopamine that it's able to be transported into a cell via the same transporters. So our body treats dopamine and methamphetamine the same way. So once we reuptake the excess meth, it is recycled and placed into these little bubbles.
And it forces the
called
dopamine
vesicles.
out.
Right. The dopamine that was there is now just in our reserve pool of neurotransmitter in the neuron. And our vesicles that are going to get released once we have our calcium influx, we have an action potential of some kind, it's going to release the methamphetamine into the synaptic cleft to be bound again. So it's going to kind of have a snowball effect. Okay, and so our excess dopamine causes our transporters to start working in reverse. Our gradients have been switched. We now have too much dopamine in the cell.
And now because we have extra dopamine in the synapse, it's going to rebind to the receptors.
Oh, okay. Forget the meth. So the dopamine that's getting forced back out because we switched the gradient around. is now binding again, which means we have even more of that reward, do it again feeling. Mm-hmm. Okay. So yeah, increases our binding exponentially. Mm-hmm. So that's interesting. That's why it's so addictive, and that's kind of that feeling of euphoria or exhilaration mm-hmm. that we're talking about here.
Especially when it happens in the reward pathway as well. It's just extra reinforcement.
There we go. Okay, so what if we look at something totally different, but like, another very common drug that we don't always think of that way is alcohol. So if we take our alcohol mouse and we see what's going on in his brain, let's see here. So GABA is the general inhibitory neurotransmitter. It's like the thing that turns everything. It's generally thought of as the thing that turns everything off. Mm-hmm. So normally we have that, and when you have a neuron that releases GABA and it receives an action potential, it releases the GABA, and that signals other cells to stop doing action potentials. Okay, so what happens in our case of alcohol if we introduce alcohol to the cell? Glutamate we think of as the brain's primary excitatory neurotransmitter, the go neurotransmitter. It makes stuff happen positively. It's mm-hmm. the opposite of the GABA, pretty much. I mean, it can change, but
I typically think of them together like opposites.
Yeah, there you go.
Okay, so we just saw the glutamate, or the GABA, no, it was the glutamate binding to the glutamate receptors.
Yeah,
basically.
Normally we'll have glutamate binding our receptors. Okay, but when we have alcohol, it increases the inhibitory effects of GABA receptors. Mm-hmm. How does that work?
Well, it binds. Let's dissect this. It's gonna bind here.
Does it open receptors that weren't previously open? Or does it change the conformational shape to make it larger?
Well, we can see that there's an area for it. Oh, so I'm wondering if it's also similar to this structure.
Is it like an adapter protein or like a co-stimulatory molecule? I'm just saying science words.
I mean, I
don't know. Mouse Party is not being super clear about this. But basically, when we have our alcohol, our GABA receptors are taking in even more GABA, which means we're having an increased amount of inhibition for mm-hmm. certain things. So what happens next?
Okay, back to the glutamate.
Okay, so our alcohol binds our glutamate receptors, which prevents the glutamate from binding because it doesn't necessarily bind. It blocks. Mm-hmm. It blocks our receptors. So our receptors aren't doing any signaling, but our glutamate can't bind because mm-hmm. the alcohol is in the way.
So it's just stuck.
It's just stuck in the synapse.
And so then it doesn't.
We're not having our excitatory signals. Mm-hmm. Oh, and so we're now in our prefrontal cortex. Mm-hmm. So our decision-making area, our impulse control, our planning, I guess that's generally what we think are.
Yeah.
Mainly the decision brain part.
And it doesn't look like it's in the reward pathway, so
it's a little bit different.
Potentially, alcohol is less addictive than cocaine and meth.
Well, at least in terms of dopamine.
Right. Yeah.
Now, I guess we can also get into other factors of addiction, like, I guess, I'm not going to say alcohol is not addictive, because it very much is.
Yeah.
We have to do more research on that.
I know, well, there's, like, the genetics, the generational genetics as well.
Yeah, absolutely.
That could play big roles, yeah.
Yeah, but I guess, so if we bring it all back to caffeine, mm-hmm. what do we find?
Yeah, so, well, you mentioned this earlier as far as how caffeine is very widely consumed in America. Mm-hmm. What I found as far as like a worldwide statistic is that caffeine is one of the world's most consumed drugs. No surprise there. With approximately 2.25 billion cups of coffee consumed every day.
Wow. I mean, that's hard to imagine
Yeah.
as a number, but
It's very hard to picture.
yeah.
Especially the fact that it's just per day and only coffee. Like, that doesn't factor in tea or chocolate. Like, that
Monster
also have
Energy.
caffeine. Exactly. So, that is a lot of caffeine that's being consumed.
It is. And it only grows in certain areas.
Mm-hmm.
Well, I'm speaking about specifically coffee and coffee beans and cocoa beans.
Yeah.
But, well,
I know. It's very interesting. And so, again, but this time more chem, a little bit more chem, and then we bring it kind of biochem a little. Caffeine, in regard to organic chemistry, is a methylxanthine.
Okay. You're gonna have to fill me in on what that is.
So this class of compound is derived from the purine base of xanthine, which is naturally produced by plants and animals, and they're all known for their stimulant effects.
Okay.
Which makes sense because caffeine is a stimulant.
Okay.
And so going forward, when I'm referring to methylxanthine compounds as a whole, it's going to apply to caffeine.
Okay.
So in the CNS, well, caffeine is classified as a stimulant, as we said earlier. And in the CNS, there's 3 notable mechanisms of action that scientists and researchers have found.
Okay.
The first, which is the primary and most common mechanism people think of and that's discussed, is adenosine receptor antagonism.
Okay.
And so adenosine is a neuromodulator that normally promotes sleep and slows neural activity. As adenosine levels naturally increase throughout the day, it binds to methylxanthine compounds like caffeine, work in part by competitively blocking adenosine's normal inhibitory actions in the brain. And adenosine and its receptors regulate neurotransmitter release and are key to processes like the regulation of sleep, arousal, learning, memory, and overall cognitive function. When caffeine occupies adenosine receptors, it prevents adenosine from binding, which is kind of what we saw with
the alcohol.
With the alcohol, exactly. How it prevented the glutamate from binding to its receptors.
Mm-hmm.
Reverse effect, because glutamate would be the stimulate.
Right. It would make it so there's less stimulation.
Exactly. Whereas caffeine is now, there's more stimulation.
Which is why alcohol is a depressant and caffeine is a stimulant.
There you go.
Because
you got it. Basically, caffeine, when it binds to the adenosine receptors, it increases alertness by removing the brake on neural firing, the brake is adenosine. And so this leads to increased neural firing and a release of stimulating and excitatory neurotransmitters like adrenaline, dopamine, and glutamate, and others as well, which results in heightened energy and alertness, ultimately influencing mood, alertness, memory, and cognition. And yeah, so the caffeine's structure is very similar to adenosine, which is why it's able to bind to the adenosine receptors.
Okay. So they bind to the same receptors.
Yeah, caffeine goes into the adenosine receptors.
Okay.
And so the second one is intracellular calcium mobilization. So this is where my thoughts were like, maybe this is why people think that caffeine affects calcium levels or pushes calcium out of the body, if we go back to the misconceptions.
Right. Are we talking about on a cellular level?
Yeah.
Because, I guess it's probably taking in and expelling calcium because we're doing all sorts of different neurotransmitter release. That needs calcium. Okay, so what do we find out here?
So methylxanthine influences intracellular calcium mobilization. Caffeine facilitates calcium movement across the sarcoplasmic reticulum and plasma membrane, leading to calcium release via the synaptic transmission in both the central and peripheral nervous systems. So neurotransmitter release depends heavily on these calcium fluctuations.
Yes.
At lower concentrations, methylxanthine enhances calcium uptake and release through the endoplasmic reticulum, or ER, whereas high concentrations inhibit ER calcium uptake. And so these effects of caffeine felt by this mechanism are not due to the suppression of adenosine, GABA, or noradrenaline, but the changes in concentration of the calcium levels.
Okay.
And so in the body, there's 3 distinct intracellular pools of calcium that have been defined by turnover rates and functional characteristics. I'm not going to get into those.
Okay.
That's a little beyond me.
But they're there.
Exactly. And of these pools, pools 2 and 3 are sensitive to the release of calcium stimulated by caffeine at low doses. Because this mechanism requires relatively high caffeine levels, it's considered less relevant physiologically than the adenosine receptor antagonism. And what I read was that it needs high levels that could lead to toxicity. So, it's definitely not one to take into consideration for
so for caffeine to have a tangible effect on decreasing your body's calcium, it would take a lethal
lot of
dose,
caffeine.
which I would assume also causes other problems too.
Yeah. Especially if it's lethal.
A heart attack.
Maybe death. The third one is phosphodiesterase inhibition. So methylxanthine prevents CAMP from being broken down by inhibiting the cyclic nucleotide phosphodiesterase, which stimulates the accumulation of CAMP. Elevated CAMP levels promote the release of hormones such as dopamine, epinephrine, and norepinephrine, which alter mood, memory, cognitive function, and alertness. However, this pathway is also thought to play a minor role in typical caffeine consumption because you also need toxic amounts of caffeine for this to be a major way. So, overall, the most significant mechanism at normal everyday doses that we consume is caffeine's role in blocking the adenosine receptors.
Okay.
Does that...
I think so. I was just looking at the if we go back to the CAMP, or the cyclic AMP, I was trying to figure out where I'd heard that before. I know it's important for neurotransmitter stuff. Mm-hmm. I think you need cyclic AMP to bind stuff, or it needs to do chemical stuff.
Yep.
And turn into different things to cause the things to happen.
Yep. Mm-hmm. That's kind of how our
brain works. It's all a big machine.
Yes, it is. Okay, so moving on to the analysis.
Okay.
After everything you've heard so far, do you think caffeine is addictive? And then follow-up question, do you think the addictiveness of caffeine, if you think there is any, compares to that of illicit substances?
Okay. Well, I think from the definitions we heard, something doesn't even necessarily need to be a drug to be addictive. Mm-hmm. So...
Right, like we mentioned behavior.
Right. So I would say, I think in that sense, caffeine is addictive because we see huge amounts of consumption. People spend, as we saw, we spend billions of dollars a year on coffee.
Mm-hmm. Worldwide.
I think of the trope of, don't talk to me before I've had my coffee type of folks. And I believe, I think that's actually a lot of us. That's more people than we might think who need coffee
or
in the
some
morning.
Kind of caffeine.
Right, some kind of caffeine to function and not have caffeine withdrawal.
Right.
So I think in that way it's a very sneaky kind of addiction. It's a very normalized one. Now, is it an addiction in the way that, I don't know, coffee destroys lives and, ruins relationships and that kind of thing? I don't know of cases like that, but you know what? I'm not going to say it can't happen. It has similar dopamine mechanisms as some drugs, which I think would be an interesting comparison.
Kind of. I'm going to talk about it a little bit. I didn't put it in before because I wanted to be and then here's this other thing.
Oh.
But yeah, it definitely does increase dopamine levels.
Okay. Yeah, so we didn't necessarily get into that. Yeah.
Yeah. So I think I completely agree with you. And so what we know so far is that caffeine affects dopamine levels indirectly, whereas with the ones that we saw on Mouse Party, at least the ones that we explored, it was very direct. Mm-hmm. So already we can kind of assume that it's less addictive than at least those drugs that directly affect dopamine levels. And then also what I found was that caffeine does not significantly increase dopamine in the nucleus accumbens. Okay. Do you remember what I said about the nucleus accumbens earlier?
I believe it's in the addiction pathway?
The reward pathway.
The reward pathway, aka the addiction pathway. I know that it was affected when we were talking about we were talking about some sort of substance use.
Yeah, where it was the nucleus accumbens is the major area for addiction.
There
basically. We go. Mm-hmm. Caffeine does not increase dopamine there. So then it's also, just from that, you can kind of infer that it's also less addictive because it doesn't influence the same parts of the brain as really heavy addictions.
Or perhaps, like, in a different way, you know?
Yeah.
Like, not in the sense of, like, this is a, you know, behavior that makes you feel euphoric and rewarded. More of, like, the alertness enables you to do things that make you, I don't know, feel better in your life, I guess. It's in a different way, in a more, maybe a longer term way.
And so instead of affecting the nucleus accumbens, caffeine, its dopamine effect is concentrated mainly in the prefrontal cortex, which still aligns with reinforcing properties, but it's not the overwhelming ones that drive the compulsive abuse. So I thought that was also really interesting, and when I was thinking of those, I was like, okay, so it's like just based off of those two, it's not going to be as addictive, right? Because of these differences, caffeine withdrawal is recognized as a clinical condition, but the APA does not classify caffeine addiction as a substance use disorder, which I thought was really interesting.
I think that is interesting. I guess if we're considering like a substance use disorder as being something that's disruptive to your life, like I know with psych disorders, you generally have it in terms of how it affects somebody's life. So, because it's so normalized, I really think you can get away with quite a bit of caffeine consumption and still have a normal life.
Right. Well, I mean, I think if, like, caffeine was stigmatized, then people wouldn't be going to a coffee shop as, like, a cutesy study time, right? It wouldn't be a common first date location. Right.
It makes us really have to look at what our contributions to addictive, quote-unquote, addictive behaviors are based on, like, how we stigmatize things.
Exactly.
Like, would it be...
Well, how we stigmatize things, and then also what we, I guess, would praise, right? Like,
what we
praise,
like
good.
Productivity and, you know, workaholic culture.
Just because of how the Western world works, it is that individualistic, get your work done before, like, doing activities for yourself.
Right. I would say it's, I guess, at least the way I think of it, the way I think it's heavily marketed with caffeine is that it helps you produce stuff for others, whereas, you know, it might still have negative side effects like anxiety or something, but...
well, especially when it's promoted to just keep taking it. Right? Like, oh, you're sleepy because you didn't get a good enough night's rest. Don't take a nap. Take caffeine. Right? And then take more caffeine later if you're still tired.
Right. That's kind of the marketing effects of, like, how we've marketed caffeine addiction into something normal. I mean...
Well, we've definitely normalized it,
absolutely.
At least. Or kind of put a blanket over it. We're not acknowledging it.
Or we consider it like maybe like something silly or like a joke.
Oh my gosh, you're addicted to caffeine. That's so cute. Me too.
Right.
But
like we don't look at, like, say, cigarettes the same way. No, I guess
you would never hear somebody say, "Oh my gosh, you're addicted to cigarettes. That's so cute. Me too." Oh my gosh, cocaine.
No, I guess I would say that, I mean, there's different health impacts, but if we're just speaking on habits, physical addictiveness, amount of use, I would say I am pretty surprised that it's not classified as a substance use disorder. It's just caffeine withdrawal is a medical symptom. So I guess I certainly experienced that, so I guess I second that. That's legit.
I think a lot of people would agree with you.
Yeah.
And so, just kind of reviewing again what we've talked about, I found this great side-by-side comparison chart from MedX comparing caffeine and illicit stimulants with different features. And so I have a blank one that I figured we could just fill out.
Sure.
Okay, so the first feature, I can just do an example, like the mechanism of action.
Okay.
We looked at how caffeine, at least the main mechanism of action, is its adenosine receptor antagonist, how it's binding to those adenosine receptors and blocking adenosine from binding.
Okay.
Whereas illicit stimulants increase dopamine either indirectly or directly. I would say most often directly in the reward system by blocking the reuptake or forcing release of dopamine.
Mm-hmm. It's a more one-to-one impact.
Exactly. Whereas
it's faster.
Right. Whereas caffeine, it's more of like a byproduct.
Right.
And you probably also, like you said earlier, how you associate caffeine with really positive experiences, you're also going to be getting dopamine release from those positive experiences. And then you're going to associate them more with caffeine later on, or like when you have coffee later on.
You're physically going to be more likely to have your brain using those
It's just
pathways.
A snowball effect, yeah. So the next one would be impact on reward system. So
if we think about what that is, I mean, I know for our illicit substance use, the impact on the reward system is, just having that drive, that need to continue use and to, I guess, reach what your brain has determined is like its homeostasis once that substance has been introduced and you become dependent. Our impact on the reward system, I would say, is less dire. It's less direct.
Right.
We're not in the nucleus accumbens. We're not in our...
Well, what we also said earlier, it's in a completely different area of the brain.
Right. So it's interacting with different areas. So our reward system is kind of in a different place. So it's much further out, I would say. It's a few more degrees removed.
Mm-hmm. The next one would be dependence potential.
Okay. Well, so, I mean, for the substances we were talking about, such as like cocaine, that is, very high potential for dependence, addiction, all of that, because of the direct impact on our dopamine systems. Caffeine, because of the neuromodulatory effects of the caffeine, we do still have a degree of dependence, a lot of people.
It's just not as much.
Right. It's not... Would you say it's because it's less directly impacting our reward system is why?
I think probably that it also doesn't lead to as great of a dopamine response.
It's like a lower dopamine hit.
Yeah. I think just with all of the factors combined, you're gonna have less of an effect. There's still gonna be some dependence potential because it's still affecting the right things, but it's not as intense or overwhelming, so it's gonna be less likely than...
Right. You're not as rewarded for drinking a cup of coffee as you
are for taking meth, yeah.
Right.
And so the next one would be withdrawal severity. And this one, I also, when I was looking into this was kind of what first came to mind, because when I think of addiction, I think of super big withdrawals.
Yeah.
And you don't really see super big withdrawals, at least they're not talked about with caffeine. I would say at most, like, the occasional headache.
Right. I guess you can certainly have headaches and more serious, like, I don't know, maybe people would have issues like staying awake during the day or something like that. But I think you can handle caffeine withdrawals. Like, I guess if you are consuming an average amount of caffeine and then experiencing a day where you're not consuming caffeine and you experience that withdrawal, that's probably going to be manageable on your own. You won't need to go to a hospital or anything.
Yeah.
But if you are, say, going through, like, alcohol withdrawals, where if you don't have a certain amount of alcohol in your system, you'll literally...
Like, you could have a seizure.
Right, you will not be well.
Yeah.
Then that's something that you would have to,
get professional help for.
Right, that's like a physical dependence issue, where your body really does depend on having that constant level.
Exactly, yeah. And, like, also there's rehab facilities for addicts, but you don't really hear of a rehab facility for caffeine, right? Like, you can have a support system with your friends and your family who are like, oh my gosh, that's so good for you, like, reducing the amount of caffeine, but you don't ever, I've never been or heard of anybody being like, oh, you are addicted to caffeine, you need help right now.
If anything, I would say caffeine could be a precursor to the other stronger things, but, that would just be speculation on my part. because we're not getting as much dopamine, because we're not directly in the reward system, because it's not as immediate of an effect, I think those are some of the protective factors of caffeine and its ability to cause some withdrawal.
And I think also, I want to go back to what I just said about the rehab facilities. I think that also because caffeine is more normalized, it does make me wonder if caffeine wasn't as normalized, would we potentially send people to caffeine rehab facilities, right?
I would imagine so. I mean, I would imagine that
if they are super addicted.
If for example, we decided to, like, do caffeine prohibition, and we criminalized it, I mean, I'm like sure
we did with alcohol.
Right, I'm sure we would see a bunch of folks who are marketed as addicts to caffeine, who need to be imprisoned for breaking the law, and it's no different than any other kind of addiction.
Yeah.
I have never heard of a caffeine overdose.
Beyond that one woman.
Oh, yeah, there
with
we
the
go.
Panera. But that's when you have excessive amounts of caffeine, and or you have a large amount of caffeine with a pre-existing medical condition. Like, it takes a lot to overdose on
Whereas,
caffeine.
on the other hand, we see, for example, like with opioid overdoses, we have millions.
Yeah, it's huge.
So, I mean, that's a very stark difference, and that sets coffee very far apart from these other drugs. There's much less, I mean, that's also because of it being legalized and therefore regulated, where we don't have that regulation for illegal substances.
Right.
So that's another factor, but also I think coffee, it doesn't have any sort of effect on, like, say, your respiration, so it's not, actually it does, but it's not suppressive, so you're able to continue to breathe.
And then the last one is societal and legal status, and we talked about this throughout, but, like, just a summary.
Right. Coffee is, like, you know, it's widely accepted, highly normalized, highly marketed, whereas these other drugs are considered to be illegal and bad and dangerous.
Stigmatized.
And we stigmatize the people who are dealing with substance addiction. And I think much of what we prescribe to people is what is how we are then seeing people. If that makes sense. You know, you are what they say you are. So if we criminalize certain substances, we associate these things with people to justify that criminalization. And it's, like I said, if coffee was treated the same way, it would be no different. Because we have regulations, because it's so popular, our coffee is safe enough, legal enough, we get by. Yeah.
And then I also want to go back to caffeine not being, like, a caffeine use disorder. And so what I was able to find about that is that the DSM-5 criteria for caffeine use disorder, it's not officially listed in the manual, but it's been proposed for further study, which is very interesting, because then it's like, there is a possibility of it actually existing, right? It's not an idea out of, like, the far left field. And the proposed criteria for caffeine use disorder would be a strong desire or unsuccessful efforts to cut down on caffeine use, continued use despite problems, and significant withdrawal symptoms, which makes sense, because, like, that's what you would see for another use disorder or substance use disorder.
And that also is going to be all dependent on the level of use.
Exactly.
How much caffeine you're really having. And I think once we have these energy drinks and such with higher and higher amounts of caffeine, these higher dosages, it's more and more likely to become more physically dependent.
Exactly. And then at what point does a strong physical dependence become an addiction?
Right.
Right? There was another one that I found from a 2014 study where caffeine withdrawal is now recognized officially as a diagnosis, and criteria for caffeine use disorder has been proposed for an additional study. Caffeine use disorder is intended to be characterized by cognitive, behavioral, and physiological symptoms indicative of caffeine use, despite significant caffeine-related problems similar to other substance use disorders. So that just echoes what I said previously.
Absolutely, yeah.
So, after all of that, that was a lot of information, but very good dialogue. So after all of that, how are you feeling? What are you feeling about the question, is caffeine addictive? Is it as addictive as illegal substances? We did just talk about this, but like for a wrap up, and then what are your takeaways?
I would say caffeine is less addictive than your average illicit substance. I definitely think there's addictive qualities, but we kind of talked about that. My key takeaways, I mean, I think there's a bigger conversation to be had about our societal, our cultural use of coffee and
for sure.
You know, the kind of messaging we have around what is a good versus bad drug. But I mean, I am going to continue to enjoy my morning cup of coffee every day.
As you should.
Maybe 2 during finals.
Maybe 3, like one in the middle of the day.
And see, is that abuse of the coffee? Who knows? And I mean, does it, at the end of the day, how much does it really matter if I'm, if I'm still getting by?
Exactly.
It's just about making it through.
So, in conclusion, when people talk about caffeine, especially online, we often hear oversimplified narratives that it can boost your brain, that it's addictive, that it's clean energy for the body, that caffeine makes you live longer, especially when it comes to black coffee. It's important to always look into these blanket statements for yourself and come to your own conclusions about what you find. Caffeine, especially in Western culture, is framed as a harmless everyday ritual with energy drinks, iced coffees. It's a little pick-me-up, yet biologically it has real and measurable effects on neurotransmission, hormone release, and behavior. When we peel back the cultural messages and look at the biochemistry, we're better equipped to make choices that actually match our body's needs, not the narratives we've absorbed. So thank you so much for listening to this first episode. If you found this interesting, or if you're now side-eyeing your morning latte just a little bit, you understand it a little bit more, you're in the right place. If you're interested in digging deeper into caffeine myths, stick around. I'll definitely come back to this topic in a future episode and explore it from a different angle, choose a different myth. It'll be so much fun. I can't wait to keep exploring these intersections of science, culture, and nutrition with you. And Zoe, any final thoughts?
Well, I actually have a silly little quiz for you and the listeners.
Okay.
I just wanted to see how good your coffee or your caffeine instincts are. So I want you to try to rank the following in order from most caffeine to least. Okay? So, I have a typical 8-ounce cup of drip coffee, okay? 12 ounces of Dr. Pepper, 12 ounces of Coke, 12 ounces of ginger ale, 16 ounces of Starbucks. I'm making you also do unit conversions.
I know. Like, okay.
And we'll do 16 ounces of Monster.
Oh gosh. Okay.
You could. I also said a lot of things, so you can just kind of vaguely respond.
I think Monster I would put at number 1.
Okay.
Then maybe Coca-Cola. What was the one that you said right before Coca-Cola?
Dr. Pepper?
I'm going to put that one as number 3.
Okay.
Ginger ale was surprising to me that it was on there. So I want to put that one last.
Okay.
So now I'm at the drip coffee and...
You got the typical drip coffee.
What was the one you said right before Monster?
What did I say? Mountain Dew?
Mountain Dew. Okay. Ooh, Mountain Dew and ginger ale being on there is very interesting. Okay, I feel like this could also be a trick question, so, but I'm gonna keep the ginger ale as last. So I'm gonna do Monster, Coca-Cola, Dr. Pepper.
Okay.
And then Mountain Dew, then the drip coffee, then ginger ale.
Interesting. Alright. You had the right instinct with ginger ale, okay? That one has no caffeine.
Okay, because that was a little, I was like, why is this one here?
And fun fact, there's also Sprite and most root beers, 7-Up, none of those have caffeine.
Okay, that makes sense to me, because I've never heard that they have caffeine in
Yeah,
them.
those ones are safe. Okay, so actually second lowest is Coke. It's only 34 milligrams and 12 ounces of Coke.
I feel like people are always like, I can't have a Coke after a certain amount of time because of the caffeine content.
I think that might just be the sugar content in a lot of these
That
cases.
makes sense.
Oh, see, there's more stuff I could have included, but okay. So, so coffee is the second lowest. Dr. Pepper...
Coffee is the second lowest?
No, sorry, Coke is.
Okay.
What am I doing?
I was like...
Coke is the second lowest. Dr. Pepper is one above that with 41 milligrams and 12 ounces. Okay. Above that, we have Mountain Dew with 54 milligrams and 12 ounces.
Okay. That's surprising to me. I didn't think Mountain Dew has that much caffeine.
Amount of caffeine in Mountain Dew.
Especially that Coke and Dr. Pepper are below that. That's very interesting.
It's weird.
Yeah.
Okay. A typical Starbucks chai latte.
Oh, I forgot about those.
I don't even know if I mentioned it.
You did mention Starbucks, but I didn't put it in my ranking.
I totally did not plan out how I was gonna do this.
That's okay.
But so a typical Starbucks chai latte, 16 ounces, has 96 milligrams of caffeine.
Okay. I'm like listening because I know that the cap for the recommended is like 300. So 97 is about a third of that, but that's still less than I would have thought.
Oh, really?
Yeah, I was thinking it would be in like the hundreds. Right?
Well, okay, so...
I mean, I don't drink coffee and I try to limit my caffeine, so my perspective is a little warped.
So our 8-ounce drip coffee is 100 milligrams of caffeine.
Okay.
And then beyond that, our Monster and Red Bull apparently have the same amount of caffeine. That's kind of cool. They both have 160 milligrams and 16 ounces.
That makes sense, especially since they're like boosters. At least that's how I see them, and I'm pretty sure other people see them as a booster, that it works faster than regular coffee.
Right.
But it just has more caffeine.
And then the kicker, the 5-hour energy, I don't even know if I mentioned that, but...
You did not.
Just so you know, 2 ounces of 5-hour energy has 200 milligrams of caffeine.
Oh my god.
Which is quite a bit. That's like
your
entire daily allowance.
Yeah.
But so don't take too many 5-hour energies, or you might actually explode your heart.
Yeah, or at least be very selective if you do take them, and like time it out well, and don't have too much of it. Do it safely.
Yeah.
That's a lot of caffeine. Wow, that was amazing.
Thank you so much for having me.
Well, thank you for the fun little quiz and for sharing your thoughts and adding fantastic additions. Like, we had a really great dialogue, and definitely this is going to be very informative.
Oh,
great way
to start off. I hope you have something to work with on here.
I think I can manage. Well, that's it for the very first podcast of Mind Over Misconception. I want to extend a huge thanks to Zoe for joining us. And I want to extend a thank you to everybody who stuck with us to the end of the episode. If you've enjoyed the podcast, please share it with someone who's ready to trade assumptions for understanding. Up next... Up next, we'll be diving into protein, the myths, the science, the history, and everything in between. Until next time, keep questioning what you think you know, and keep putting mind over misconception.